Today I'd like to just record an example again, a second example. And here's the information on this particular example. So here we have a study of oral contraception. We're going to abbreviate that OC. Oral contraceptive, it was looking at oral contraceptive use and development of an infection called bacteriuria. This was conducted among 2,390 women, all of whom were initially free from bacteriuria. Okay, notice this, all of whom were initially free. This should suggest to you exactly what type of study design this is right there. At the start of the study, the women were surveyed to determine whether or not they currently used OCs, oral contraceptives. 482 were using OCs and 1,908 were not. By the end of the follow-up period, a total of 27 of the ones using the OC, the oral contraceptive users, and 77 of the non-users had developed bacteriuria. Okay, so you should start noticing some things right away. 27 of those using oral contraceptives ended up infected. 77 of the ones who didn't. So you see that there's a difference and that actually more of the non-users had developed the infection, but you can't just compare those numbers because there were different numbers of women using the oral contraceptives. Notice 482 used oral contraceptives, but 1,908 did not. So it's more than 4 times as many who did not use the oral contraceptives. So of course, you know, it's a smaller group that used them, so you would expect fewer cases in a smaller group. So that's going to be taken into account when we do our calculations. Okay, so that's all the numbers we need. Conduct a hypothesis test. So totally ignore the rest of the questions until we finish doing the DEP model hypothesis test. So the key things we need to notice in here, all of whom were initially free at the start of the study. We find out if they're, so which thing here is the exposure and which thing is the outcome? Well, it should be clear from even the order they talk about it. Oral contraceptive use is going to be your exposure and bacteriuria will be the disease outcome. So they initially do not have bacteriuria. So it's clearly not case control. They're not talking about assigning women randomly to get oral contraceptives, so it's not experimental. So that pretty much leaves cohort because it is one of the study designs that is prospective. It's going to follow women over time, right? A follow-up period. They're looking to see if they develop the outcome. So this is cohort study. So we will not be using odds ratios, but rather risk ratios, exactly like the ones that we developed and calculated together in Chapter 3. Okay, so let's go to the form. Okay, so starting out here, I realized that on the screen, what's written on here is probably not totally legible. Other than hypothesis testing form for PUH 295, so that's us. And we have Nitsa case thinking, and then Nahata planning, Ina living, Siasin assurance. So we're going to go in that order around here, but in order to video this more clearly for you, I'm going to zoom in. We're going to go one direction at a time here. Okay, so in Nitsa case, we are thinking about all the different elements, you know, what it is that's being asked, and what it is we really want to understand. So the type of data, we talked about using oral contraceptives or not, and then we talked about getting bacteriuria or not. So we have categories. People are in categories, use or not use, got the disease, didn't get the disease. They are, so these are categorical data. And the particular form of categorical data is that they are dichotomous, two values. Okay, so with this kind of categorical data, we're going to be putting it into a 2x2 table. And when you're putting it in a two-way table, the conditions that are required are that the expected values in each cell have to be greater than or equal to 5. And the claim to be tested. Okay, so because we're looking at an exposure of oral contraceptive use and an outcome of an infection called bacteriuria, we're going to be testing the claim that there is a relationship, or you could say association, between use of oral contraceptives. I'm running out of space, so I'm going to just abbreviate like they did, and getting this infection bacteriuria. Oops, that's an IA here. Okay. All right, so those are the things to identify in your thinking, that we know it's a cohort, we have exposure and outcome that are dichotomous, two values each, so we'll put it in our comfortable two-way table that we're so used to. We need to check to make sure the expected values in each cell are 5 or more. And the claim we're testing is that there is a relationship between the exposure of use of oral contraceptives and getting this infection called bacteriuria. All right, so it's time to move then around clockwise sun direction to Nahata planning. All right, so the H with the little O, that's your null hypothesis. The null hypothesis is that there's nothing going on here. There is no relationship between OC use, oral contraceptive use, and bacteriuria. I'm just going to abbreviate it there for us. Okay, then the H1, the alternate hypothesis, this is our claim to be tested in this study, is that there is a relationship. And it's the same wording afterwards between OC use and bacteriuria. Okay, this Greek letter here, the lowercase alpha, the first letter of the Greek alphabet, this stands for the level of significance of the test. So this is to be our cutoff for whether we're going to find the results significant, statistically significant or not. So if the p-value is less than 0.05, then we're going to reject that null hypothesis and conclude that there is a relationship. Otherwise, we're going to stick with the null hypothesis that there is no relationship. So this is the number to watch when we get to the end. Compare your p-value to this to see whether or not you find there is a relationship or you find there's not a relationship. The test statistic for these kinds of data is to use the chi-square. Chi, not chi now. Okay. the effect measure, the measure we're going to use of how strong the relationship is between the exposure and the outcome, in this case is going to be the RR, the risk ratio, just exactly like from chapter 3 where we get the rate in the group that uses the oral contraceptives, and then we'll get the rate of the illness in the ones that do not use the oral contraceptives. We're going to divide and get this risk ratio, and that will be what we look at to see if there's much of a relationship there or not. All right, so we've planned the whole thing out. We know what our hypotheses are, we know our cutoff or significance level, we know the test statistic to use, the effect measure to use. So we go do it. All right, so we're going to go around here then to enough, living, carrying it out, carrying out our plan. Okay, so we need to get our observed values table. All right, so this is the first time we actually look back to the actual problem. They gave us some numbers. We're going to use those numbers. Let me just stick that in a place where I have some space here. Okay, so it's going to be a two-way table, and there'll be sums. Okay, totals. Make this a little bit bigger so we can see the whole thing. All right, so over here we have our exposure. So we're going to have the ones who use the oral contraceptives, that's the exposure, and the no OC will be the non-exposed, the unexposed. Up here we have cases of bacteriuria, and then the other column will be no bacteriuria. Okay, so switching back to the data. Okay, so it says here that it was 2,390 women all at once. So it's a good idea to just go over here and fill that in. We know that's your overall total. This is the total number of women in the study, so that's where that would go. Okay, at the start of the study, figure out if they had used OCs or not. 482 did, 1,908 did not. So those are our exposed totals, so those also go in the totals. So 482 women used oral contraceptives, 1,908 did not. Then just check and make sure this adds up. Right, 2 plus 8 is 10, so 0 carry 1. 1 plus 8 is 9, plus 0 is 9. 9 and 4, 13, 1 carry 1. All right, so it works. Now the next thing is, what are the other numbers? All right, so then they told us at the end of the follow-up period, 27 of the exposed got the illness, 77 of the others. So 27 of those who used oral contraceptives and 77 of the non-users got the bacteriuria. So total number of cases this way is 104, and now we have to just fill in these other numbers. Okay, so 482 here. So 482 minus these 27 will give us 455. You can verify that with a calculator, do the additions, make sure it works. And if you subtract the 77 from the 1,908, you'll get 1,831. Again, you can get that total. And then make sure that the 104 plus the 2,286 does in fact give you 2,390, and then you'll know that all of the numbers in this table are exactly correct because they add up in all possible different ways. Okay, so that is our observed values table. You may choose to put that on another piece of paper. You can easily insert a table with 4 columns and 4 rows in a Word document and fill in the blanks. That would be an easy way to create that table. Okay, so the next thing we want to do is we want the effect measure, which was the RR. We want the test statistic, which is the chi-squared. And then we want the p-value. So we've got a bunch of things to go get here. So we're going to run over to our handy website. Okay, so back over to Blackboard, back to the biostatistics folder, and about halfway down. Table Statistics Calculator. So here's our calculator. Here's where we're going to put in our numbers. Remember that they switch their columns. The condition absent, so the condition is bacteriuria, so we want this first column to be the ones who did not get bacteriuria. So that's going to be our second column. So we're going to put in 455 and 1831. Okay, and then for the condition present, that's going to be the ones who did get bacteriuria, so that's 27 and 77. Okay, make sure those all look right, and then hit your calculate. And look over here at the expected frequencies, and they are all well over 5, so no problem there. All right, so we go down here. We were looking for a risk ratio, not an odds ratio, so we're going to grab this 1.4. We're going to round it to 1.4. Okay, so I just wrote that as the risk ratio. And then might as well grab the confidence interval. Okay, so we go down to the next area. Sorry. So risk ratio observed here again is the 1.4. So the lower limit is 0.9, the upper limit is 2.1. So 0.9, 2.1. So in parentheses, 0.9 and then comma 2.1 and then end your parentheses. So this is interval notation for the confidence interval. This tells you that we're 95% confident that the real risk ratio in the population is between 0.9 and 2.1. This is trouble, all right? You should already notice this is a problem because this is less than 1. Remember that if the risk ratio is 1, that means there's no relationship, which basically is what the null hypothesis says. All right, there's no relationship. So we can't be 95% sure that it's not 1 or somewhere even less than 1, meaning there's no relationship. So this already should clue you into the fact that probably there's no relationship. If you recall the example from yesterday, this number here was 1 point something, meaning that we were pretty sure that it was not lower than 1. Okay, what about the chi-squared value? So back over to the website, move down to the next little area. Chi-squared, we want the Pearson chi-squared, so that's a 2.27. I would just grab that whole thing, 2.27, and then we want the p-value for that. So the p-value is right below it, right? Here's the p row, and it's the one that's right under the Pearson, so it's 0.1319. Let's just grab 0.13 from that. Or you can put 0.13 if you feel more comfortable having that 0 there. It doesn't really matter. Okay, so this pretty much confirms what the confidence interval already suggested, right? This p-value is not less than 0.05, right? So it's not less than 0.05, it's more than 0.05. Okay, so it's time to finish this off and think about what the answer is here. So our conclusion, since the p-value was not, right, the p-value was 0.13, so that's not less than 0.05. So that means that we are not going to find that there's a relationship. With this p-value, we're not going to reject the null hypothesis, as they say in statistics classes. We're going to stick with that null hypothesis that there is no relationship. So what you can write here is that the sample, this was a sample, the sample evidence does not support a relationship between OC use and bacteriuria. Okay, I'm running out of space here, which is another reason why you might want to put some of this discussion and interpretation on another document. If significant, report effect measure. Was this significant? No. So we're going to put NA here. It only is significant if the p-value is less than 0.05. So this is not significant. So we're not going to talk about the risk ratio of 1.4 that we found. There's no point using it because we do not have evidence that there's a relationship. So forget about the OC use of the bacteriuria. All right, the last thing you can do then is return to the problem and see if you can now easily answer the questions. Is this a cohort study, case control study, or experimental? We already know it's a cohort study because we found them and put them in groups according to their exposure, and then we watched over time to see whether they were going to get the bacteriuria. So that's a cohort study. We did not start with people who had the infection and go backwards, and we did not tell them to use oral contraceptives or not, which would have been experimental. You could fill in the 2x2 table here. We already wrote it somewhere else. The risk ratio, we calculated that to be 1.4 with a confidence interval 0.9 to 2.1. And based on your hypothesis test, do you think that oral contraceptive users are at higher risk of developing bacteriuria? And the answer is no. There was not enough the sample evidence was not enough to convince you of that. So you can put that concern to one side. Okay, so that's the end of the hypothesis test here, and you can maybe use that to do the two problems in homework 11, do them exactly the same way. I don't know which way they're going to come out. That's for you to figure out, whether you're going to support the claim that there's a relationship or whether you're going to reject that. So